Now, countries around the world are racing to develop a supercomputer based on quantum physics. And South Korean researchers are really on the cutting edge of developing innovative ways to turn this transformative tech from theory, as it currently is, to reality. Soo-young with more.
South Korean researchers are working on the building blocks of supercomputing networks that are hundreds of thousands of times faster and more secure than present-day technology. Quantum computing researchers at Korea Institute of Science and Technology have developed ways to use diamond structures to generate qubits. Normal computers store and send data in binary form as either ones or zeros. However, quantum computers use qubits, which can exist as a 1 and a 0 at the same time, in what's called a state of superposition. As both possibilities exist, this increases the amount of data the computer can store or process, meaning it can run through all possible outcomes at once. However, it's not just the number of qubits that matter. As they're largely volatile, keeping them isolated and in a workable state is one of the biggest hurdles in quantum computing.
We use SPIN-QUBITS to develop our system. The advantage of using nitrogen vacancy color centers in diamonds to make qubits allows them to work better at room temperature, and there is also good connectivity with photons. We can also incorporate semiconductor processes to produce qubits.
Scientists around the world are working to obtain the quantum advantage, or reach the point where quantum computers can significantly beat traditional computers at solving complex problems. Most expect this would require at least 50 to 100 stable qubits. Quantum cryptography is another promising field, being the closest commercial application of quantum technology. From using secured Wi-Fi to controlling power grids, encrypted networks are vital to security on individual, business, and national levels. Using the quantum principles of physics could help make networks unhackable. A secret key is distributed between two parties and cannot be intercepted without collapsing.
Traditional networks are secured with mathematical problems or encryption, which can be resolved and thus hacked. But by using random values and the BB84 protocol, we can check error rates to detect hacking attempts. While quantum network equipment has mostly enabled data centers to connect with a single receiver or client, we have successfully tested a system with multiple receivers.
Han's team aims to develop this multiple receiver system and make the equipment smaller while increasing the distance of data transfers. Korea's Science Ministry aims to invest more than $37 million over the next 5 years to develop a 5-qubit quantum computer and a 100-qubit machine by 2027. Soo-young, Arirang News.